Hello, today we're going to look at addition of rational numbers, and this is just the first part. Our learning target for today is going to be, I will learn how to add rational numbers with different denominators. So let's begin by looking at the word problem. A football team gains 11 yards on one play, then loses 5 yards on another play, and loses 2 yards on a third play. What is the total yardage, loss, or gain? So a loss can be expressed as a negative integer. A gain can be expressed as a positive integer. To find the net gain or loss, the individual values must be added together. So therefore, the sum is 11 plus a negative 5 plus a negative 2, and the answer is 4. The team has a net gain of 4 yards. Addition can also be shown using a number line. So if you need to add 2 plus 3, start by making a point at the value of 2 and move 3 integers to the right. The ending value represents the sum of the values. So if I take a point, mark it on 2, and I jump 3 spaces, I go 1, 2, 3, I end up at 5. So 2 plus 3 equals 5. So example 1, find the sum of negative 2 plus 3 using the number line. So here's how it would work. We're going to mark our beginning point at negative 2, and we're going to go 3 spaces again. 1, 2, 3. We jumped 3. So 1 is our answer. So negative 2 plus 3 equals 1. When the value that is being added is positive, we jump to the right. If the value is negative, we jump to the left in a negative direction. So example 2, find the sum of 2 minus 3 using the number line. Here again, we're going to start at 2, and we're going to take away 3. So we are going to move to the left. We're going to go 1, 2, 3. And that 3 brought us to a negative 1. So the solution of 2 minus 3 is negative 1. Now in lesson 2.1, you learned the additive inverse property. This property states that the sum of a number and its opposite is 0. Algebra has many other properties that help you to manipulate and to organize information. So remember, a sum, if I take A and I add it to a negative A, it's going to equal 0. And that was the additive inverse property. So let's take a closer look at the commutative property of addition. For all real numbers A and B, A plus B equals B plus A. So what this means to commute, it means to change locations. So the commutative property allows addition for you to rearrange the objects in an addition problem. Then we would have the associative property of addition. So for all real numbers A and B and C, A plus B plus C equals A plus the sum of B plus C. To associate, it means to group together. So the associative property of addition allows you to regroup the objects in an addition problem. Then you have the identity property of addition. So for any real number A plus 0 equals A. This property allows you to use the fact that the sum of any number and 0 is the original value of that number. So let's look at example 3. We're going to simplify the following using the properties of addition. So if we look at A, we have 9 plus the sum of 1 plus 22. We can use the associative property and we can regroup the numbers to have it make sense. So if I were to group 9 plus 1, 9. If I regroup 9 plus 1, and then I add it to 22, I'm going to be able to figure out this much easier because 9 plus 1 is the same thing as 10. 10 plus 22 equals 32. And because of that associative property, I can do that. I can regroup those because I know with addition, doesn't matter which order I add them in, I'm always going to get the same answer. Now let's look at B. We have 4,211. Using the identity property of addition, I know that adding any number to 0 is going to be that number. So 4,211 plus 0 is just 4,211. And that would be using the identity property of addition. So let's try a word problem. Nadia and Peter are building sand castles on the beach. Nadia built a castle 2 feet tall, stopped for ice cream, and then added 1 more foot to her castle. Peter built a castle 1 foot tall before stopping for a sandwich. After his sandwich, he built up his castle 2 more feet. Whose castle is the taller? So Nadia's castle is 2 plus 1. Let's see. So Nadia's castle is 2 plus 1 feet tall. Peter's castle is 1 plus 2 feet tall. We know that because they gave us that information. Nadia, she built 2 feet and then added 1 more. And Peter, he built his 1 foot tall, and after his sandwich, he added 2 more feet. So by creating an equation, we can figure it out. According to the commutative property of addition, the 2 castles are the same height. If I look, 2 plus 1 and 1 plus 2, 2 plus 1 is 3, and 1 plus 2 is also 3. So we can prove that they are the same height. So we're up to adding rational numbers. So to add rational numbers, and rational numbers are fractions. So to add rational numbers, we must first remember how to rewrite mixed numbers as improper fractions. So begin by multiplying the denominator or the bottom number of the mixed number by a whole value. Add the numerator to its product. The value is the numerator of the improper fraction. The denominator is the original. So let's test this out. Example 4 is asking us to write 11 2/3 as an improper fraction. So we're going to start by taking 11 times 3. We would multiply the bottom number times the whole number. 11 times 3 is 33. And then we're going to add 2. So 33 plus 2 is 35. So 11 23rds is equal to 35 thirds. So we know if we take the bottom number times the whole number plus 2, we can rewrite a proper fraction, a mixed fraction, as an improper fraction. Now that we know how to write a mixed number as an improper fraction, we can begin to add rational numbers. There's one thing to remember when finding the sum or difference of a rational number. The denominators must be equivalent. So what that means is that bottom number, they have to be the same when we're adding. The addition property of fractions for all real numbers, A, B, and C, is A over C plus B over C equals A plus B over C. So what that's showing is the denominator must all be the same.